Okay, now as you have got in 2D, there are two types of packing. One is square close packing and one is hexagonal close packing. If you want to know, suppose I have supplied some marbles to you and you want to arrange the marbles two-dimensionally. So you can arrange the marbles two-dimensionally as square close packing or as hexagonal close packing. But do you know in which packing the gap you will get less? I mean the vacant space you will get. Here you can see number of vacant spaces are present inside the particles. These vacant spaces, these are called void actually. So here number of voids you will get, I mean number of gaps you will get in between the particles. But here in this case you will get less number of void in between the particles, because maximum space you can occupy when you arrange the particles like hexagonal. So that is why this type of packing is said to be more stable, and you will get more density for this type of packing as compared to the square close one. So that is why when you arrange the particles, your target should be minimum vacant spaces should be present and maximum spaces should be occupied by the particles. So in two dimension, hexagonal close packing have more stability than the square close packing, because in hexagonal close packing you will get less amount of vacant spaces as compared to square close packing. So this is in 2D, but we know in solid they always have the 3D packing. So we have done 1D, 2D. Now we will move to the 3D arrangement. It is very difficult to draw the 3D arrangement. How to make it 3D? See, from the 2D we will make it 3D. So when you make 3D, from this square close packing you can make 3D, and from this hexagonal close packing also you can make 3D. Now, when you make 3D structure, how to make it 3D? This whole layer you consider as one layer. Above this layer you have to place another layer. Then it goes to 3D. Then above the second layer you have to place another third layer. Then it goes to three-dimensional structure. So that's why it is very difficult to draw the 3D structure. But I'll show you how to draw the 3D structure. So now I'll make 3D structure from this 2D packing. First time I'll make the 3D structure from the square close packing in 2D. So now close packing, this is number 3, close packing in 3D. I mean close packing in 3 dimension. So number A, I will do close packing 3D close packing from 2D square pack layers. So now I will draw the 3D packing from 2D square pack layers. I mean, as you have got, this is one layer of particles, this is another layer of particles, this is another layer of particles exactly above the second layer, like this. Then this is called the two-dimensional structure. This type of packing is called square close packing. Now if you want to make it 3D, this whole layer I consider as A layer. If you place another layer of particles above this layer, suppose above this particle one particle, above this particle another particle you place, above this particle you place another particle. So like this way, if you place the second layer, then it goes to 3 dimension. Similarly, above the second layer you place the third layer exactly above the second layer. Then since you place the second layer exactly above the first layer, that's why second layer is also named as A. And that is why this type of arrangement is called AAA type arrangement. AAA type arrangement. And in this type of packing, after placing second layer, third layer, fourth layer, the whole structure goes like to be a cubic structure, and that's why this type of packing is said to be a simple cubic packing. Simple cubic packing in 3D. This is one of the packing in 3 dimension. I have shown 2D only, but you imagine that here above another layer is placed above this, another layer is placed above the second layer, like that. Now when you arrange the particles like this way, ultimately the overall structure you will get like this. See the arrangement. It's difficult to draw the 3D. Just I want to show you. You will get the arrangement after placing number of layers. You will get this type of packing. Ultimately, this type of packing you will get, and this type of packing forms a cube type structure. That's why this type of packing is called simple cubic packing. I mean, this is one layer. Above this layer you have to place another layer exactly above the first layer, then you have to place another third layer exactly above the second layer. Then the arrangement goes to like this. This is one layer exactly above, this is second layer, this is third layer, this is fourth layer. I mean, if you consider this one as A layer, this one will be A, this one will be A, like this. I mean, that is why this type of arrangement is called AAA type arrangement, and since it forms a cubic type structure, that's why this type of packing is called simple cubic packing in 3 dimension. And here you have seen, if you want to find out the coordination number, this is one particle, this particle, see, particles are spherical, you don't consider it as circle, these are spherical one. I mean, like marble. One marble, one particle is shared by 4 particles in each layer. In its own layer, one particle is touching by 4. When you place another layer above it, one particle will touching, one marble will touching to this marble. From the below layer, another one particle will be touching with this. I mean, total 6 particles will touching this particle. From its own layer, 4 particles will touch. From the above layer, one particle will touch. From the below layer, one particle will touch. I mean, one particle is touching by another 6 particle. That is why in simple cubic packing in 3 dimension, the coordination number is found to be 6. So these coordination numbers are very important. In exam, the question will ask in 2D hexagonal close packing, what is the coordination number? In 2D square close packing, what is the coordination number? In 3D simple cubic packing, what is the coordination number? This type of question will ask, and that is why you should know about the coordination number in different types of arrangement. So have you got it? Actually, it is very difficult to draw the 3D structure in board. That's why just you have to imagine the structure. You consider the particle as marble, and you can take some marble, and by taking marble, first you place one layer of marble, then you place another layer above the first layer marble, exactly above the first layer, then you place second layer. When you arrange the marble like this way, then you will get this type of packing, and it will form a simple cube, and that's why this type of packing is called simple cubic packing in 3D. Mainly you should know about the 3D structure, because solid always form 3D structure, and that is why first time I have done 1D, then 2D, then goes to 3D. Solid have 3D structure, but directly if you do 3D structure, you cannot understand. That's why first time we have done 1D, then 2D, then we move to 3D. So this is one type of packing in 3D structure, and this packing is called simple cubic packing in 3 dimension. And this packing we have made from square close packing in 2D. Similarly, you can make the 3D structure from the 2D hexagonal close packing also. So this is one type of packing. Different types of packing you will get in 3 dimension. This is one of the packing which is called simple cubic packing in 3 dimension. and in this type of packing the coordination number you will get 6. So in next class we will do the 3D packing from the 2D hexagonal close packing. Thank you.